Are you tired of seeing public spaces littered with water bottles? Tired of picking up bottles off the ground? Well, you're not the only one. 22 billion plastic water bottles get thrown away rather than recycled every year in the US. Furthermore, more than 60 million plastic water bottles are thrown away every day, many of which end up as litter in streets, parks, and waterways. It is evident that plastic bottles are a critical source of litter in the US, which means that the endeavor to reduce the litter in public areas is high effort in terms of resources and manpower. That's where the RecycleBot comes in, a solution to plastic waste that employs a machine learning and computer vision-based bottle detection system housed on an iRobot to autonomously search, detect, and pick up plastic water bottles. Here is a video of our RecycleBot in action. It is going towards the first water bottle, turns on the intake, and then intakes the water bottle. And now it's going in different increments to find the next water bottle. Once it sees the water bottle in the frame, it centers itself and then goes towards the water bottle, turns on the intake, and intakes it. And now it's continuing to look for more bottles and sees this one, centers it, and intakes itself. After this, it's going to continue to do the same pipeline until it goes a full 360 degrees counterclockwise without seeing a bottle. And so once it doesn't see the bottle, it's going to stop. Now, we have a video where there is an obstacle present. So it picks up the first bottle, but then it avoids the obstacle and only sees the water bottles because the obstacles will be classified as obstacles. Now, to go deeper into how the RecycleBot works. On the left, we have the physical components of the RecycleBot, and on the right side is an abstracted diagram of the components and connections. The 11.1 volt battery powers the Jetson Xavier NX, the brains of our system containing the entire software pipeline. The Jetson takes in color and depth images from the RealSense LiDAR camera. It is also connected to the iRobot via UART to send navigation commands to the iRobot. To allow the intake to spin, the Jetson is connected to an Arduino Uno, which commands the motor driver. The motor driver then controls the rotation of the intake motor and is powered by an 18-volt drill battery. Now, to go deeper into the software pipeline, we first have our Intel RealSense LiDAR camera on the very left, which sends real-time color and depth streams to the Jetson Xavier NX at 60 frames per second. Many of our modules use color frames to determine if there are objects and their bounding boxes, and depth frames to estimate the distance between the RecycleBot and other objects. Next, we run inference on the color stream of the LiDAR, which is the process of running an image through our machine learning model that we trained to detect obstacles and bottles. The output of inference is an image with bounding boxes on all detected objects and their classification. Here are some examples of some of the inference outputs. Here we have the bottle on the very bottom left. Here we have the bottles classified a little bit more far away. And then we have an obstacle that's classified here. And here we have obstacles and the bottle classified. Next, we go into target selection. And so given the set of bounding boxes from inference, we need to select the bounding box of the closest bottle. After that, we use the KCF object tracking algorithm to track the position of the selected bounding box while commanding the robot to rotate left or right to center the bottle in the center of the frame. Once the selected bounding box is in the center, we command the robot to stop rotating. After that, we perform a second round of inference to detect bottles that may have appeared after angle calculation. And then we use object tracking again to see how close we are to our target as the robot moves forward to ensure that we can avoid any obstacles in the way. Here are the results from our testing and the testing environment that we used. We primarily tested in TechSpark, where we picked a 1 meter radius on the floor and placed 3 randomly placed water bottles in that 1 meter radius. And then we have the RecycleBot start at one of the edges on the circumference of the circle. And our first classification of testing is just 3 bottles. And we have the metrics that we set out for ourselves on the left, and then how our robot performed. So we have 100% bottle detection accuracy, 93.3 pickup success, 89.41 seconds for the entire trial to run, and then a 0% bottle false positive rate. Now, for the second type of classification of testing, we have 3 bottles and 3 obstacles. And for this type of testing, we had 91.67% bottle detection accuracy, 100% obstacle detection accuracy, 50% obstacle avoidance success, and 100% pickup success. Here is another video of our RecycleBot in action. Yay. Here is a picture of us with our RecycleBot after getting second during our demo day. And overall, this was a super, super great learning experience, and we are very proud of our work and what this class has taught us.